Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present assignment 2, theory of structure. We given the purpose question: draw the influence line diagram for reaction, shear force and bending moment for simply supported beam. Simply supported beam which one hanging and simply supported beam which two and hanging. Calculate the maximum shear force and bending moment at a certain section of beam using the influence line diagram for a beam subject to a set moving loads. Analysis the absolute maximum moments in a simply supported beam subject to a series of moving point loads. So the topic is influence line for statically determined beams. What is influence lines? An influence line can be defined as the graphical display of variation of a specific statistical or geometrical quantity at a section in a structure when a unit load rolls move over the entire structure end to end. The ordinate of the influence line diagram at any section is the value of a quantity when the unit rolling load is placed at the section. So the topic is 1. Influence line diagram of a reaction, shear force, bending moment. Second is maximum influence at a point due to a series of moving loads. 3. Absolute maximum shear and moments. So the influence line can be determined the value for an x. Second is solve the reaction shear moment. 3 is tabulate data. 4. Plot the graph. 5. Determine the influence line equation. So the application of influence line is you need to determine the reaction by using influence lines when x less than a more than 0 while x distance from left support to unit load. The formula is like this. And you need to sketch of influence line for reaction at A just like this. So the second unit, when x less than L more than A while x distance from left support to unit load. The formula is this, and the sketch of influence lines of our reaction at B like this.
I will continue with B to determine shear force by using influence line. This is example for determine shear force. First is when x more and equal 0, x less and equal A, where x equals distance from the support to unit load. The formula is in the box. Second, when x more and equal A, x less and equal L, where x distance from the support to unit load. The formula is in the box. C. To determine bending moment using influence lines. When x more and equal 0, x less and equal A, where x distance from the support to unit load. The formula is in the box. Second, when x more and equal A, x less and equal L, where x is equal distance from the support to unit loads. The formula is in the box. Substitute x equal A into the formula in the box, and lastly x equal L into the formula in the box. And this is example for bending moment.
Okay, thank you Zahirah. So now the analysis is place a unit load at a various location x along the member, and at its location use static to determine the value of the function reaction shear moment at specific point. Okay, the second is if the IL for a vertical force reaction at a point on a beam is to be constructed, consider the reaction to be positive at the point when it's at upward on the beam. Okay. The third is if a shear or moment IL is to be drawn for a point, take the shear or moment at the point as plus VE according to the same sign convention used for drawing shear and moment diagram. Okay, last, all statically determinate beams will have IL that consists of a straight line segment. After some practice, one should be able to minimize computation and locate the unit load only at point presenting the end point of each line segment.
So for me, I would like to present my part for the calculation for my assignment. So in this question, we got vertical reaction at A and B, shear at C, moment at C. So by the looks of the figure above, we can do our solution for the vertical reaction at A first. So as you can see at this diagram or IL diagram, first we got from A to 4/6 is 2 meter. From 4/6 to 2/6 is 2 meter, and from 2/6 towards B we got 2 meter, which is the total the distance between A and B is 6 meter. So we use the formula, which is RA equal to 20 multiplied by 4/6 plus 50 multiplied by 2/6 plus 15 multiplied by 1/2 multiplied by 4 multiplied by 4/6. We got the reaction at A is 50 kilonewtons. So that is for reaction at A. For reaction at B, it's the same output, which is 6 meter for the direction from A towards B. We're using RA equal to 20 multiplied by 2/6 plus 50 multiplied by 4/6 plus 15 multiplied by 1/2 multiplied by 2/6 plus 1 multiplied by 4 at the end. So we got 80 kilonewton for reaction at B. So for the next reaction, for shear force at C, by looks of this diagram, it has the upside down force or upside down diagram. One upside down and one is one is the normal side of the diagram. So for this reaction, we got the negative and positive part. So at the positive part is 2 meter and 2 meter. For the start of this upside down to point B, we got 4 meter. So for the formula is VC equal to 20 multiplied by 4/6 plus 50 multiplied by 2/6 plus 15 multiplied by 1/2 multiplied by 4 multiplied by 4/6. So we got 50 kilonewton. So after that, we continue with the calculation, which is VC equal to 20 multiplied by negative 2/6 plus 50 multiplied by 2/6 plus 15 multiplied by 1/2 multiplied by 4 multiplied by 4/6. So we got 20 kilonewton. For this, this is different type of reaction, which is the above. For the above is positive, for the below is negative. So after find the shear force at C, we have to find the moment at C. If you look at this diagram, it has point A, point C, point B. The diagram is it's upside down. So for the moment, the calculation is MC equal to 20 multiplied by 2 multiplied by 4/6 plus 50 multiplied by 2 multiplied by 2/6 plus 1 multiplied by 5 multiplied by 1/2 multiplied by 2 multiplied by 4/6 and multiplied by 4 at the back. So we got 100 kilonewton per meter. So that is for me, for my part. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL AMIRAH binti YUSOF. This is our conclusion. In engineering, an influence line graph the variation of function at a specific point of a beam on truss caused by a unit load placed at any point along the structure. Some of the common function studies with influence lines include reaction, the force that the structure support must apply in order for the structure to remain static, shear moment and deflection. Influence lines are important in designing beam and trusses used in bridge, crane rails, conveyor belt, floor girders and other structures where loads will move along their span. The influence lines show where a load will create the maximum effect for any of the function studies. Okay, that's all from us. Thank you.